Hello, I want to share with you The Right Way to Fly, a lesson plan from the Summer of Innovation lessons on engineering and aeronautics. My name is Mike McGlone, and I am a NASA curriculum specialist with the Aerospace Education Services Project. In this first segment, we will look at some background information and then build and test a simple sled kite. In 1903, the Wright brothers ushered in the age of modern aviation with the first heavier-than-air flight, which led the way for today's space age. But the history of flying goes back into ancient history. Before their airplane, the Wright brothers and many others tested ideas and concepts as gliders. And before gliders, balloons and other lighter-than-air vehicles were developed. And going even further back in history, kites were used in ancient China for military purposes, fishing, and farming. We can use a modern version of this ancient tool to learn about flying. Today we are going to investigate the basics of flight by testing several different kites. A simple sled kite in this first segment and a trapezoidal kite in the second segment. For our first kite, we need the materials pictured here. A copy of the sled kite template from the lesson plan, 2 straws, string, a paper clip, tape, crepe paper, and a hole punch. I also have a jumbo-sized craft stick that we will talk about more in a moment. First, cut out the kite from the template, then tape the straws in place along the dotted lines and fold a piece of tape across each of the places labeled tape. If the straws extend a little beyond the bottom edge of the kite, that is okay, or you can cut them to size. Now use the hole punch to put holes through the dark circles we reinforced with tape. Next, cut a piece of string 16 to 20 inches or 40 to 50 centimeters in length and tie an end through one of the holes in the kite and the other end through the opposite hole. Your kite will look something like this. One of the challenges of this step is how well students can tie knots. Younger students can also have problems with the fine motor skills sometimes needed for knot tying. Now we need to prepare our flying string. Cut about 5 meters of string from the spool. A hint here, crochet thread works well and is fairly cheap for this activity. Tape one end of the string to a jumbo craft stick and wind the string around the stick. There are other objects you can use besides the craft stick, paper tubes, pencils, etc. But I think jumbo craft sticks work very well for this activity. After winding our flying string, it is time to attach this to our kite. You can tie the flying string directly to the center of the small string on the kite, or as pictured, use a small paper clip to connect the 2 pieces of string. We are almost ready to fly. But there is one last element we need to add, the tail. The tail is the key to this activity. Students will experiment with how the kite flies with and without a tail, plus with different types of tails. Students can change the length and number of tails on their kite, or even change the type of material. Another hint, have the students start with long tails and then tear the crepe paper to test shorter lengths. Now go outside and have some fun testing your sled kites. We will build and test our trapezoidal kites in the next segment. Good luck. Hello, I want to share with you the second part of The Right Way to Fly, a lesson plan from the Summer of Innovation lessons on engineering and aeronautics. My name is Mike McGlone, and I am a NASA curriculum specialist with the Aerospace Education Services Project. In this second segment, we will build and test a trapezoidal kite. Today, we are going to investigate a basic flight principle by testing variations on a single kite design. As mentioned in the first segment, the historical use of kites to test flying concepts goes back to the Wright brothers and even further back in history. Our objectives for today include predicting the effect of a kite sail area on kite flight, measuring a trapezoidal kite, and using reflections. Plus, we will be calculating area of a trapezoid and calculating the aspect ratio. More later on aspect ratio. And if you watch the video noted in the lesson plan, which I highly recommend, you will learn how kites influenced early flight. That video also includes additional directions on how to build the trapezoidal kites. Today we will build 3 versions of a trapezoidal kite. I recommend breaking the class into groups of 3 so that each student can build and test their own kite, but the group can compare the results. All we need for the kites are a sheet of 8.5 by 11 inch copy paper, a bamboo skewer, scissors, tape, tail materials such as crepe paper or strips of plastic bags, and string. Some colored pencils or markers to decorate the kites would be appropriate as well. Students will also need copies of the worksheets from the Educator's Guide. Before we begin building, each student needs to know which kite they are building. I usually post this information in the classroom and poll the students in each group who is building Kite A, Kite B, or Kite C. To build our kites, everyone will start with a sheet of paper in the landscape position, also known as hamburger in some circles. Fold the paper in half. Next, depending on which kite each student has, they will measure from the fold line and mark points A and B. For Kite A, this would be 3.5 centimeters and 9 centimeters respectively. Next, we reflect those measurements to the other side of the point fold for points A prime and B prime. Now, fold along the AB and the A prime B prime line to form the sail and backbone of the kite. Fold in along the center fold, then fold back along line segments AB and A prime B prime. This will form the kite shape as shown in the figure. Be sure the backbone of the kite is perpendicular to the span of the kite or it will spin uncontrollably. Tape the two segments of the kite sail together, completely sealing the connection. Next, tape a bamboo skewer across the span of the kite, point C to D as shown in the inset. Cut any excess off the end of the bamboo skewers. Next, measure 7 centimeters down from point F and 1 centimeter in from the fold to punch a hole for the kite string. Add your string and a tail and you are about ready to go fly. Now that the kites are built, it is time to make some measurements and calculations. Measure and record the length of the bases B1 and B2 plus the height h of the kite. Use the formula for the area of a trapezoid to determine the area A of your kite. Be sure to double the answer to get the entire kite area. The formula in the student guide includes a 2 to double the area so students calculate the proper area. Next, measure the span of the kite. This is the distance from point C to point D, the length of the skewer we added to this kite. Now you can calculate the aspect ratio of the kite, which is a ratio comparing the span to the area of the kite. Engineers use aspect ratios to predict how kites and other flying objects will perform. In this activity, we will determine which kite has the best aspect ratio based on performance. Be sure to write all measurements, calculation, and observations on the student worksheets. Now your students are ready to go fly. Before you go outside to fly the kites, discuss the observations and measurements your students will make while flying. Now go outside and have some fun testing your trapezoidal kites. After flying, discuss the results with students. Have fun testing how shape and aspect ratio affect kite flying.